Hi everyone, today we're going to be talking about the relationship between physical activity and cardiovascular disease. So first let's talk about what specifically is the definition of cardiovascular disease. It is a whole group of disorders related to the heart and blood vessels, so it's really a broad, all-encompassing term. You can see the picture on the top shows the heart obviously, and then the red vessels that you see are arteries, the blue are veins, and all of the muscle, bone, organs, etc., except for the heart, are pulled away in this picture, and so you can see the vast amount of complication there is with these blood vessels. It's a pretty incredible system that supplies blood to the entire body. So if you have damage to any of these vessels, that really is cardiovascular disease. And then the picture that you see on the bottom right is showing the arteries that supply the heart muscle itself. Those are the coronary arteries, and coronary artery disease is one of the most common forms of cardiovascular disease. So this is when you have damage to these vessels that supply the heart tissue itself, and typically a blockage in a coronary artery results in what we call a myocardial infarction or a heart attack. That means that there is no blood being supplied to a particular portion of the heart, and depending on which portion and how much of the heart determines the outcome of that heart attack. Is it survived? Is there a lot of damage? Is it fatal? And so forth. Other types of cardiovascular disease include cerebrovascular disease. This is the vessels in the brain, so a stroke would be part of that category. Peripheral artery disease is disease of the peripheral arteries, which are arteries that supply our periphery. Typically we think of this as the limbs, the hands and feet, arms and legs. And so peripheral artery disease is actually highly associated with diabetes. There tends to be poor blood flow with diabetes, and this can cause numbness, tingling, weakness in the extremities. Rheumatic heart disease is inflammation of the heart. Congenital heart disease is any heart disease that someone's born with or that has a genetic component. A deep vein thrombosis is a clot deep in a vein, and these in and of themselves are not particularly dangerous, but if they travel to the heart or the lungs and rupture, a rupture in a lung is called a pulmonary embolism, and these are often fatal. So preventing and or treating these clots is very important. So the point really is there is a whole host of conditions that all together are termed cardiovascular disease. So this is showing cardiovascular disease in males, specifically the distribution of deaths due to the variety of cardiovascular diseases. So the red shows ischemic heart disease. Ischemia means lack of blood flow. And so these are conditions that result in lack of blood flow, basically for the most part, heart attacks really. The green is cerebrovascular disease, so this basically represents stroke. And so you can see that between heart attack and stroke, those are by far the most common causes of cardiovascular disease death, and then there are a few other conditions that contribute as well. This is showing basically the exact same information except in females. You can see the trends really are quite similar. Ischemic heart disease and cerebrovascular disease are by far the most common causes of cardiovascular disease death in women. So what causes cardiovascular disease? You could probably list some things that you've heard are risk factors, and these are shown on this figure. If you look on the x-axis, you'll see attributable deaths. So this is similar to what we learned to calculate the attributable risk. So you're seeing comparisons of the number of deaths that each of these risk factors has caused. So indoor smoke from solid fuels, childhood underweight, and we tend to think of overweight as being risk factor for cardiovascular disease, but poor nutrition and development, particularly underweight in childhood, is actually also strongly associated with cardiovascular disease. Use of alcohol, unsafe sex, high cholesterol, overweight and obesity, inactivity, high blood glucose, tobacco use, and elevated blood pressure, in that order. What I want you to notice, though, specifically with physical inactivity, is that physical inactivity is actually a risk factor for a lot of these other risk factors. So physical inactivity is related to high cholesterol, overweight and obesity, high blood glucose, and raised blood pressure. And so in some ways, it's probably the most we could change physical inactivity and have a very great impact, because it would change all of these other risk factors also. Next, let's talk about cholesterol. Cholesterol is actually necessary for life. It's contained in every body cell. It gets this bad rap, but in some ways it's very good. It's necessary for a lot of functions, but the problem is when there's too much of it. So what you see in this picture is that the liver produces cholesterol. Actually, your body can actually make this compound, and we get it from the food that we eat, specifically animal products, so meat, eggs, and dairy products. It's carried in the bloodstream by these proteins, lipoproteins actually, called LDL and HDL, which we'll talk about on the next slide. And again, it can be made from either the human liver or consumed in the diet, because it's made by the liver of all animals. And so what you see in this picture on the bottom is the inner lining of a blood vessel. So now we're going to talk about cholesterol and its role in the blood vessel. So what happens is that you want a nice, healthy, open space in your blood vessel for blood to flow through easily. Well, LDL can basically, if there's ever damage to the inner lining of your blood vessel, that happens in everyone, and there are mechanisms that our bodies have to repair that. But LDL, what it does is it sticks to those spots of damage, and then it triggers a cascade where other cells, foam cells and some different types of immune cells come in and try to repair it. But the cholesterol, it causes this, basically a clot to form. And that's what you see starting to develop in portion B of this picture. And then in C, the thrombus is the actual clot. There's all this junk, for lack of a better term, building up in this artery, including a whole bunch of cholesterol. And you can see it progresses from C to D, and you have a much narrower space for blood to flow through your artery. And there's essentially this, kind of think of it like a sore, a wound inside your blood vessel. Well, if this breaks off, it can travel somewhere else in the body and cause a complete blockage. Depending on where that happens, it can be very dangerous or deadly. So let's talk about the lipoproteins LDL and HDL, and these are essentially carriers for cholesterol. So LDL is sometimes called bad cholesterol. It stands for low density lipoprotein, and HDL is high density lipoprotein. And what HDL does is it scrapes away plaque, LDL cholesterol, from the walls of the arteries. So it's good. It prevents all of that bad stuff that we saw on the previous slide from happening. So you want your HDL level to be high. LDL causes deposits of cholesterol in the walls of the arteries. So it promotes the formation of these blockages or plaques. And so this is sometimes called bad cholesterol. You want your LDL level to be low. Here you see the ideal levels of LDL. You ideally want your LDL level to be less than 100, and milligrams per deciliter is the unit. And then you can see near optimal, borderline high, and so forth. Very high, a cholesterol level, an LDL level of 200, for instance, is considered very high. And then there's total cholesterol, You want that number to be less than 200. There are actually other types of cholesterol in addition to LDL and HDL, so that total cholesterol accounts for all of that. And then HDL, this is good cholesterol. Remember, you want your HDL to be high, so an HDL less than 40 is bad. It's considered increased risk for heart disease. There's also something called triglycerides. What this is it's a stored form of fat, and these float around in your bloodstream. And high levels of fat in your blood is associated with high cholesterol and heart disease. Now let's talk briefly about what blood pressure is. I'm sure you've all had your blood pressure measured. You may have even measured it on someone else. And so this is the pressure in your arteries when the heart is contracting and also relaxing. So anytime you have your blood pressure measured, they'll give you two numbers. Typically it's some number over some other number, 120 over 80. The first number that you get should be the highest, and this is your systolic blood pressure. It's the pressure during the contraction phase of the heart, when the heart is pumping. And then the second number is the diastolic blood pressure, and this is the pressure when the heart is relaxing or filling up with blood. And so again, the systolic number should be higher than the diastolic. And you can see in this diagram, ideally, you want your systolic blood pressure to be less than 120 and your diastolic blood pressure to be less than 180. Hypertension is pathologic high blood pressure. It's disease. And this is classified as a systolic pressure of 140 or higher and a diastolic pressure of 90 or higher. So hypertension is the medical term for high blood pressure, and really it sounds kind of innocent, oh, high blood pressure, but it's very dangerous. It is associated with what's called atherosclerosis. This is just buildup of plaque in your arteries. It's basically the condition that we saw on that slide previously where the plaque formation was happening. That's atherosclerosis. This can lead to heart attacks. It's related to blood clot formation. It's associated with congestive heart failure, which is when your heart muscle gets really weak and just basically gradually stops working. If your blood pressure is high, your heart has to work really hard, essentially. And so over time, it makes your heart weaker. Here's pictures of atherosclerosis. On the bottom, you can see the yellow area. That is plaque formation. That's bad. And then in the very bottom right portion of that picture is a clot. And so if that artery becomes blocked off by a clot, completely blocked off, then you can't have blood flow through there. The picture on the top right is a heart muscle cross section. See how that muscle is very, very thick? This is a bad thing because what's happened is the heart has had to work so hard because blood pressure is so high that when a heart works really hard, the muscle gets bigger. And in some cases, muscle getting bigger is good, but in this case, that muscle is encroaching on the space where the blood can fill in the heart, so not much blood can fill, therefore not much blood can be pumped out, and this person is probably very lethargic, tired, weak, and has a hard time doing much of anything, honestly. Next, let's mention smoking. Smoking is actually a very strong risk factor for heart disease because what it does is it damages the lining of the arteries, which is called the endothelium. So it basically allows for plaque to form. So if you have high cholesterol and you smoke, that's particularly dangerous because there's that damage and then the cholesterol sticks to it. Smoking also elevates blood pressure and lowers good or HDL cholesterol. So all of those things together contribute to heart disease risk. So now let's get into what this module is really about, is physical activity and how does this affect our risk of cardiovascular disease. So physical activity results in the release of a chemical called nitric oxide. Nitric oxide is a vasodilator. So if you go to to the optometrist, you get your eyes dilated, the pupils open up wide, and more light comes in. So dilation means opening up. So if a vessel dilates, it gets wider. So what happens to blood flow? If the vessel gets wider, blood flow goes up. If more blood can flow through, the pressure doesn't have to be as strong. So it actually lowers or normalizes blood pressure. It promotes lower LDL, that's bad cholesterol, and it raises HDL, which is good cholesterol. It increases what's called stroke volume. This is just how hard your heart can pump. So it makes your heart muscle stronger, is another way to think about it. And it lowers your resting heart rate. If you're really physically fit, it lowers your resting heart rate. This basically means your heart doesn't have to pump as often. It's not working as hard. The Framingham Heart Health Study is a cohort study, a very famous cohort study that began in 1948, and it is funded by part of the NIH, the National Institutes of Health, which is essentially a government funding agency for biomedical research. And its objective was to identify risk factors essentially for cardiovascular disease. So we tend to take for granted that we know what causes cardiovascular disease, but we've really only known this for about 60, 70 years. So the Framingham study, what they did was, again, it's a cohort study, so they recruited many people who lived in this little town in Massachusetts that coincidentally was called Framingham, Massachusetts. Originally there were 5,209 men and women. What they did is they did extensive physical exams. They asked very detailed questions about what they ate, how active they were, smoking, all kinds of lifestyle questions. And then they had the participants come back every 2 years to do the same thing over again. And so they were able to follow these people up over long periods of time and look at what types of lifestyles were associated with risk of heart disease. They now have a second and a third generation, so the children and grandchildren of the original participants. So that's allowed them to look at some of the genetic risk factors as well. There is a risk score, a Framingham risk score that you can calculate based on data from the Framingham study. What it does is it calculates your risk of heart disease in the next 10 years, and it's based on your age, your cholesterol level, whether you smoke or not, your HDL, and your blood pressure. So if you're interested in this, you just Google Framingham risk score, and there are all kinds of calculators online for you. For most of you who are young, healthy people, your risk scores are going to be very, very low, if nothing else based on your age. But you can do this for a parent or grandparent as well and help them to see what their risk might be like. All right, let's talk about lipids specifically in relation to physical activity. So blood lipids are your cholesterol and your triglycerides primarily. So this study is a meta-analysis. What it is it's a study of a whole bunch of other studies. So essentially the point here was to see, does diet lower blood lipids, does exercise lower blood lipids, and does the combination of diet and exercise lower blood lipids? So the first section here on the screen under diet is obviously that portion, studies that looked at diet and their effect on blood lipids, and then the middle section is exercise, and then the bottom section is studies that looked at both diet and exercise. So the way this is set up is that there's this solid line at 0 for a change in, this is total cholesterol TC. Any of the black squares to the left of the 0 line mean a decreased blood lipid level. So that's good. We want decreased blood lipids, or decreased total cholesterol is associated with less heart disease. Any black box to the right is that study found an increase in total cholesterol. And then these kind of blue diamonds, that's the the weighted average of all of those studies in that section. So the blue diamond towards the top for diet shows that overall these several studies found that a diet intervention decreased total cholesterol by about 10 units. Now if you look at the exercise, there was no effect of exercise on total cholesterol. But if you look at the diet plus exercise at the diamond, it is to the left about 15 units. So really what this suggests is that diet alone impacted blood lipids, exercise alone did not. The best scenario was the combination of diet and exercise. So this is set up exactly the same way, only the outcome is LDL, bad cholesterol. And you see something very similar. Diet changed blood lipids by about 5 units. Exercise did not change LDL, but the best outcome was with the combination of diet and exercise. And then this is HDL. So you actually want your HDL to increase, to be to the right on this diagram. Remember, HDL is good cholesterol. And you can see that all three of the diamonds, they're really basically not different from that 0 line. So what this says is that neither diet nor exercise, nor diet and exercise combined, really impacted HDL cholesterol. And we've seen that in other studies, that HDL appears to be pretty genetically determined. There is some other data showing that a diet high in omega-3 fatty acids, which is commonly found in fish, is the best, to my knowledge, that's the best dietary way to increase HDL. So let's talk about fitness. That was all diet and exercise. But we know that exercise or physical activity doesn't always correlate exactly to fitness. So this figure is a little confusing, but I'm going to try to explain it the best I can. There's a reference group here. It's on this diagram. It's in the bottom right-hand corner. It says reference. So what you see is people who, over time, they either lost weight, kept their weight stable, or they gained weight. That's represented by BMI change. And then you also see people who gained fitness, they got more fit, or they stayed the same, or they lost fitness, they became less fit. And this is looking at cardiovascular disease mortality. So if the box is higher on the figure, that means the mortality risk is higher. And so the reference category is people who lost weight and gained fitness. That's the ideal scenario. What I want you to see specifically is in the bottom left-hand corner of this figure. People who, even though they lost weight, if they lost fitness, their mortality risk was 2.01, or twice as high as people who lost weight but gained fitness. What this suggests is that weight loss is not as valuable as fitness gain, or losing fitness is really dangerous for your health. It doesn't really matter in terms of cardiovascular disease mortality risk. It doesn't matter what your weight is like, it matters what your fitness is like. So if people want to reduce their risk of heart disease, often they worry about weight, but really this suggests that what you ought to worry about is your cardiorespiratory fitness. How can your body use oxygen? And we can improve fitness by exercise. All right, here's one more important concept to talk about. This is showing, again, it's a little bit complicated, but on the x-axis there's all these different blood lipid markers. HDL-C, HDL2C, HDL3C, these are different types of good cholesterol. So you want HDL to go up, and then you see On the bottom figure, B, cholesterol, TG is triglycerides, LDL is the bad cholesterol. And so what they did is they took a whole bunch of people, measured all of these outcomes at baseline, and then they had them do an exercise training program over several months. And then they measured these outcomes again. Let's look specifically at figure A for a moment. The white bars are normolipidemics, people with normal blood lipids, healthy people. The gray dashed bars are people who just have low HDL or low good cholesterol. Otherwise, they're healthy. The gray bars are people who just have high triglycerides. And then the black bars, this is the group you don't want to be in. They have high triglycerides and low HDL. So what I want you to notice with the HDL changes is the group that changed the most was the black bar. The people who had bad lipid levels. If you look down at figure B, who had the greatest decrease in cholesterol and triglycerides and LDL? It was the high triglycerides, low HDL group, the people who had bad blood lipid situations. So what I think this means is that people who are worse off to start, they're the ones that exercise is impactful for. You saw those meta-analyses on a few previous slides that basically said exercise doesn't do anything, which is kind of discouraging. But I think maybe the reason we think that, based on some research, is that it does something for people who have adverse blood lipid profiles, but it doesn't do anything. They already have normal. Look at these white bars. It doesn't do anything for people who have normal cholesterol and triglycerides because they have normal cholesterol and triglycerides. So the impact is seems to be in people who have who are worse off. Coronary heart disease. This is, just to review, disease in the vessels that supply blood to the myocardium, that's the heart muscle. And a blockage is typically what causes a heart attack. So this study was called the San Francisco Longshoreman Study. It was a study of occupational physical activity, people who were longshoremen, meaning they worked on the docks and fishermen and that type of thing. Okay, so on your x-axis here you have work activity in kcals per week. So further to the right means they burned more calories working. Basically, they were more physically active at work. And then on the y-axis is relative risk of a fatal heart attack. And so you want lower on the figure means a lower risk. So what you see with this figure is that more work was associated with lower risk of a fatal heart attack, suggesting that occupational physical activity lowers coronary heart disease. This is set up very similarly. It's from the Harvard alumni study. Instead of occupational physical activity, it's leisure time physical activity. So the black line is participation in vigorous sports. The dashed line is participation in other physical activity related activities. Both of those were associated with lower risk of coronary heart disease. Vigorous sports in particular lowered risk. All right, lastly, let's talk about cerebrovascular disease, stroke. So a stroke is defined as a loss or impairment of bodily function resulting from injury or death of, that should be brain cells, following insufficient blood supply. So it's basically a heart attack in the brain. It's not enough blood flow to the brain. You can also have mini strokes that are called transient ischemic attacks, or TIAs. This is when for a short period of time blood flow to a particular region of the brain is reduced. So stroke signs, sudden numbness or weakness of the face, arm, or leg, especially if it's only on one side. Sudden confusion, trouble speaking or understanding, sudden trouble seeing, sudden trouble walking, dizziness, loss of balance, sudden severe headache with no known cause. Notice that all 5 of those start with sudden. It comes on very, very quickly. A stroke is, again, a blockage to an area of the brain. That's what you see on the left picture, a blockage in some artery somewhere in the brain. The effect is going to depend on where in the brain it occurs. On the right-hand picture, you see that gray area. That's basically dead brain tissue. So whatever function occurs in that area of the brain, that function is going to be affected by this. This is a prevalence map. This data is from the BRFSS. That's the system where they call and ask about all kinds of health-related conditions. And so what you see here is that on average, 2.4% of U.S. adults have had a stroke or have been told that they've had a stroke. And you can see how that varies by state. So lighter colors mean a smaller percentage of the population has had a stroke. The darker the color, the greater the percentage of strokes. So Mississippi, Alabama, Oklahoma, Arizona, in those states, more than 4% of the population has actually been told they've had a stroke, which is, to me, a very alarming statistic. Risk factors for stroke are very similar, if not the same, as risk factors for heart disease, hypertension, smoking, alcohol abuse, cholesterol, obesity, diabetes. And you can see that low physical activity is included in this table 6.1 on your screen. The population attributable risk is 29.4%, which means that if we got rid of low physical activity, if everyone was physically active, 29.4% of stroke cases would go away. So I just told you that basically that yes, physical activity does reduce risk of stroke. Here's some of the data. Here's how we know this. This is from a study done in Birmingham, England, based on what they called regular vigorous exercise. The gray bar is people who did no exercise. The darker gray bar is people who exercised when they were young, and then the dark bar is people who exercised all the way through until age 55. And so this is showing that lifelong physical activity is important, but even if you just exercise during a portion of your life, that also reduced risk of stroke. So this is suggesting that stroke risk starts very early on in life. This is from the Northern Manhattan Stroke Study. You see something pretty similar. People who don't exercise at all have the highest risk of stroke, and then vigorous activity lowers the risk even more than light to moderate activity, but light to moderate is still good. And then it also shows less than 2 hours a week of activity versus less than 5 hours a week versus people who get 5 hours or more. And there is a difference there, but it's not considerable. Here it looks like any activity reduces your risk of stroke considerably. This is showing, again, basically the same thing from a different study, Harvard alumni study this time. So repeatedly, different studies have shown the same thing. Physical activity decreases risk of stroke. That's consistency. So this week you're going to it should say today, sorry. Today you're going to participate in EPI in the News 3. And then please remember that we will not have a module on Monday. That is a university holiday. So we will resume class on Tuesday.